Hello students, welcome to the next lecture of the design and analysis of algorithm, and in today's lesson we will talk about merge sort and we'll analyze merge sort. In the previous lessons we had already seen few algorithms, like we had seen shell sort, we had seen selection, insertion, and in today's lesson we'll talk about merge sort. So let's see what we are going to talk about merge sort today. We'll talk about the concept of the merge sort, then we'll talk about the time complexity, and then we'll talk about the space complexity of the merge sort. So let's begin with the merge sort. This is basically a divide and conquer approach. So that is means we will divide the larger problem into sub problems and then we'll conquer those sub problems. So the merge sort is basically can be done into three major steps. The one is divide. That means we need to divide the larger problem into smaller sub problems, and then into the second step we need to conquer with the help of the recursion, or we can sort the sub list and then we can recur. Then the third is actually merge. So we need to merge those smaller sorted list into a larger sorted list. So this merge sort is basically about three steps: divide, then conquer, and then merge. So we have a large set of this array, then we'll divide it into smaller ones, we'll sort them, and then we'll again merge them back into the sorted array. So this is how this merge sort works. So let's see a smaller algorithm for this merge sort. So this is a merge sort where we have A as the array, P is the initial index. Let's say we have 1, this is the initial index, and R is the high index, that is the last element's index. So this merge sort will continue if P is less than R. If we have P, the low end is smaller than the R, that means we have some elements into the list, then this will continue. What we need to do is, first we need to find out the mid element of this larger list. So we'll find out the mid element, that will be called as Q. So let's say if you want to find out the mid element of this, so how many elements we have? We have 1, 2, 3, 4, 5, 6, 7 and 8 elements. So how we need to calculate Q? This Q will be let's say 1 plus 8 upon 2, this will be 9 upon 2, 4.5, and logically this is fourth element. So the mid element of this will be the fourth element. So what will be the fourth element? 1, 2, 3 and 4. So we can see here that in the first division, this is Q comes to be the mid element. So in the first step we need to find out the mid element, and then we need to divide this larger list into two equal subparts, or into two smaller subparts. What will be these two subparts? One from P to Q and the other from Q plus 1 to R. So this will be subdivided into two smaller sublists. So let me subdivide this. So this will be subdivided into two smaller sublists. One is from P to Q, that is with 15, 10, 5 and 20. So this is from P to Q. And the second one is from Q plus 1. So what is Q plus 1? This is Q plus 1. So this will be 25, 30, 40 and this is 35. So this is from Q plus 1 and R. So this is the first step, is called as the division. So we have divided this into two smaller subsets. Then we'll recursively call this and keep dividing these till we achieve the smallest list. So now we need to go to the left hand side, and again we need to do this because we are calling this recursively. So we need to go this. Now this is the low end P, this is the higher end Q, and again we'll find out the mid element and then we'll divide this into two smaller subsets. So let me divide this into two smaller subsets. So now this will be 15 and 10 is the one list, and here it will be 5 and 20 will be the second list. Again we'll go to the same thing in this, we'll subdivide this. So this 15 and 10 will again be divided into two smaller sets, 15 and then this is 10. This will be divided into 5 and then this will be into 2. 20. The same process will happen onto the right hand side. This will be subdivided into first this is 25 and 30, and here it will be 40 and 35. Then this will be subdivided into 25 and 30, and this will be divided into 40 and 35. So this is the divide step that has been performed recursively. So we need to conquer this by merging and then performing sorting. So let's see how we can do this. So this was the first step, merge sort the left hand side part. So we have done the left hand side part, and again the merge sort onto the right hand side part. So this right hand sublist will again be divided, and then we'll perform a merge operation. So this is an important thing, how we gonna merge. So once we have got the smallest elements, then we are going to merge them back. And in such a way that this new list is a sorted list. So let's see, this is 15 and this is 10. So once we merge them back, this will be, let's say if I am going to merge it, so this needs to be the new element, that is 10 and 15. If I am writing this into the ascending order, so once I merge, this will be 10 and 15. That is in the sorted order. I'll show you how this sorting is done. So we have merged this into 10 and 15. Then again we'll merge these two elements. So this will be merged and this will be 5 and 20. These two will be merged together, and this will be 25 and 30, and these two will be merged together, and this will be 35 and 40. So remember, while we were merging this, we created the sorted list. So this is 10 and 15 sorted, this is 5 and 20 sorted, this is 25 and 30 sorted, and this is 35 and 40 sorted. Now again the merging will be done. So now we'll merge these two lists together, and just to merge these two lists together, we make sure that once we'll merge them, the new list needed to be a sorted list. So let me write this sorted list here. If I want to merge this 10, 15, 5 and 20, so this will be something, let me write it here, let me eliminate this, and so we have 5 here, then we have 10, then we have 15, and then we have 20. So this will be the sorted list. So once we'll merge these two, we'll get this sorted list. And now once again on the right hand side, we'll merge this. Again, while merging, we need to make sure that this results into a sorted list. So let me write the sorted list here. So we are merging back. So now this will be 25, 30, and then this will be 35, and this will be 40. So we can see that these two lists are merged into another sorted list, and these two lists are merged into another sorted list, and finally these two lists will be merged into this sorted list. So this is how the merge sort operates. Let me perform the final step as well, because this is the merge operation as important. So let me show you how these merging is done. So we'll create a new empty list. So we'll create a new empty list with the similar size. So we have 4 plus 4, 8. So this will be created with the 8 positions, and now we'll start. So this is, we'll say this is I, and here we'll move with J. So this is I and this is J. So this is 1, 2, 3, 4. J is 1, 2, 3, 4. So first of all, this J is equal to 1, 5 will be compared with I is equal to 1 will be compared with J is equal to 1. So we'll compare. If this 5 is smaller than 25, then we'll put this 5 here into the empty list. So we'll put this 5 here. Let's call it K, and this K is 1 right now. So what we did, we compared the initial indexes of I and J of this first list. Let's call it left list, and let's call it right list. So we'll compare this left list and right list. and whichever the smaller element was kept into this new list. Now we need to increment the indexes, right? So if you can see, if we put the element of this list into the new list, then this I will be incremented, and if the element from this list will be substituted into the list, then j will be incremented, and in both the cases k will be incremented. So in our first case, we have put the element of this left list into this new list, so the I will be incremented. So now this I will be 2. So now we will be comparing this 10 with 25. So this 10 with 25, which is the smaller? 10 is the smaller. We'll substitute 10 here, right? So k is again incremented 2, so we'll substitute 10 here. Then again, now from which list we have substituted? From this list, so we will increment this I again. So this I is incremented. Now we are on to this third element. So this is 15. So if we'll compare this 15 with this 25, which one is smaller? Obviously 15. So we'll put 15 here, we'll increment, and now again, which variable will be incremented? This I will be incremented, and this will go to 20. So now this 20 will be picked. So this is 20. Again, this will be incremented, and now we are left with no elements into this. So we'll keep adding the elements from the second list into this new list, because we know that this second list is already sorted. So this is 25, 30, 35 and 40. So this is how merging is done, because we need to take care that while merging, the new list has to be a sorted list. So this is how a merge sort operates. Now let me show you what is the complexity, what is the time complexity of this merge sort. We can see the time complexity of this merge sort with the help of this example. So let's say if this is taking order of 1 time, because it's just a comparison, then this is finding out the mid element, will be taking the order of 1, because it's just finding out the mid element, its operation. Now the merge sort, and you can see that we are performing a recursive call onto the half element, so that is n upon 2. So for this, the order will be n upon 2, and then again this is the right half, the opposite half, so this will be of order of n upon 2 again, because here we are sorting another half element. And lastly, this is a merge operation. That means we are merging all the n elements together, so this will be of order of n. So now if we'll combine this and we'll form a recursion relation, so this will be the order of 1 plus order of 1 plus order of n upon 2 plus order of n upon 2 plus order of n. So ignoring these constant values, we have twice of, let me write it in the function of t, so twice of t of n upon 2 plus t of n. So this is, we can see this is the recurrence relation, and the solution to this recurrence relation is n log n. So the time complexity of this merge sort comes to be order of n log n. So this is the time complexity of this merge sort. Now let me talk about the space complexity. So we can see that just to store these this list, we need the array or the size of n. So the space complexity, we can see here it is, we need space complexity of 1. Let me write it here. Let me write the space complexity. For this we need a space complexity of 1. For this we need space complexity of 1. Again for this we need the space complexity of n upon 2, and for this space complexity of n upon 2, and for this space complexity of n. And you can see the highest space complexity in this is of order of n. So the space complexity of this merge sort comes to be of order of n. So this is the time complexity, order of n log n. We could calculate this with the help of the recurrence relation, and this is the space complexity of the merge sort. So I hope you have understood the concept of the merge sort. If you have any confusion, feel free to comment into the comment box and clear out your queries. In the upcoming lectures, we'll be talking about more sorting algorithms and we'll analyze them with respect to the time and space complexity. Thank you so much.